Do you know how AI agents delegate tasks to different tools and how to make AI agents autonomous? So in this video, I'm explaining you all of this. Hi guys, welcome to Freebird's Q. And everybody talking about AI agents using DeepSeek, OpenAI and Google Gemini. But what if I told you most of them are designed wrong? And today, we are breaking down agentic AI design patterns and the secret framework that actually make AI agents work. So if you are using AI agents alone without agentic design patterns, they are not aligned with the objective. They can stuck in the infinite loop of feedbacks or hallucinations. They can struggle to prioritize and adapt to the environment. But with agentic design patterns, they can align with the objective. They can have enhanced decision making. They can have scalability, consistency, and can easily adapt to the environment as well. So if you want to build AI agents that are more autonomous, adaptable with the tools and environment, and powerful with the reason, this video is for you. So let's dive in. So first question is, what are agentic AI design patterns? So agentic AI design patterns are the blueprints for building smart AI systems where multiple agents work independently. Okay, so as you know, AI agents have the ability to operate independently, make decisions, and can improve based on the data and the experiences. But using these patterns, they have a common workflow and they can easily interact with the environment by using tools such as APIs, databases as well. So just take an example of software development lifecycle in which you provide a framework to build a software. So similarly, agentic AI design patterns provide a framework to build AI agents in which they can work more efficiently and can complete the given task without hallucinations. Okay, so now the question comes, how many agentic AI design patterns are there? And when to use which pattern, and how to build agents with these patterns, and how to connect them with the tools. So don't worry, I will explain everything in this video with Python code and Autogen Agentic AI framework by Microsoft. So here are the 5 agentic AI design patterns. So first is reflection pattern. Then we have the ReAct, tool use, planning, and multi-agent patterns. These patterns are the best for you and nowadays as well. Patterns everywhere, I understand, but these patterns help build agents more robust and scalable as well. So let's learn about each pattern one by one with Python code and Autogen. So first we have is reflection pattern. This pattern actually enables the AI agent to evaluate and refine their outputs by self-assessing and self-checking their performances and outputs. That leads to higher quality and high reliability outputs. Okay, and you can use them when your task requires very high accuracy and quality, such as code generation or complex problem solving. Okay, and this reflection pattern works as the main large language model will generate output. The judge large language model reflect on that output, suggest improvements or modifications if any required, and then the main large language model will implement those improvements and suggestions and then go back to the judge large language model for the further improvement and suggestions. This loop will keep on going until the judge will say that your output is correct now. Okay, so in that iterative work, this reflection pattern will work. Okay, and you can avoid using this pattern if you are doing just a simple task where using this iterative method is very time consuming as well. Okay, and the best example of this pattern is self-reflective RAG, where your text generation will get improved by retrieving the relevant information on demand and using the reflection tokens to judge the quality of the output. So that's how the self-reflective RAG will work, and I will make a separate video on that to explain how the self-reflective RAG will work, and we can also make a project on that as well. Okay, so now let's implement the reflection pattern by using the Python and the Autogen Agentic AI framework. Okay, so we have this Python notebook here in which I am explaining all the agentic AI design patterns. So first we have the reflection pattern. As you know how it works, it is keep on reflecting on its output until the output is correct. Okay, we have a requirement list here. We need a large language model with the API key, or you can use a Hugging Face open source large language model. Okay, so I am using here Gemini. Okay, let me just see. I'm using here Google Gemini Flash LLM. Okay, Flash 2.0 LLM here. Okay, so for that I get my own API key here, and I specify my model name here. I just built a function, reflect and improve. So for that, I just first load my this Google Gemini model with the help of a Google GenAI library. Okay, and for that I just build a client mode generate with the help of the model, and then pass my prompt here, and then this is initial text that I have. Okay, and then I have the reflection prompt, so that the kind of answer that I get from here, I need to reflect on that by using the same model. Okay, so it just reflect on that and provide me the answer. So in that way, it you can get initial text and also the improved text in that format. So when I display my initial answer, you can see this is my initial answers. Okay, and when I display my improved answer, the improved answers are much better and much more clear explained as well. Okay, so that's what you can get from the reflection pattern. But in this way, that thing is not autonomous, right? If you need to make it autonomous, you need to make it agentic AI framework here, and that can be done by using the Autogen. And when using the Autogen, you can install these kind of libraries first. Okay, and after installing these kind of libraries as well, you need to specify the large language model here as well. So here I am using the Gemini 1.5 Pro, and along with my API key, and mention my API type as the Google as well. Okay, so first I make a AI agent here that is called as the writer. I make the agent with the help of a Autogen library. I called the assistant agent kind of a function here. I name the agent writer. I message a system prompt here that you are a writer, you want to write the blog post, blah blah blah. Okay, then I also add my large language model configuration that it can use to generate the answers. I give it a task that write a concise but engaging blog post on AI agents in 100 words. It can give me a blog post. Okay, it's very small, 100 agents blog post. But what if I tell this agent to reflect back? So for that, I made a new agent here that is called as critique agent, that you want to criticize on this kind of blog post that I write and give me the improvements as well. So for that, I pass my large language model configuration here, and then the system prompt is here that you are critique as well. And for that critique, I just pass my chat here, and in that way, I just pass my recipient here. My recipient is the writer, that is the same writer I just made above, and this writer will try to complete this task, but now with the critique in it as well. Okay, for that I just add the task here, and then our max returns is 2, and the summary message is last message. And this can a agent will work continuously on multiple iterations until the result is approved by the critique as well. Okay, so as you just see, it goes to the critique, it write a blog here, this is the blog, and then the critique to the writer will say you need to add some constructive feedback here, and then the writer will apply this kind of feedback, and the task is completed. Will write a complete kind of blog post on the AI agent. So in that way, this whole thing will work. This whole thing work only on the 2 turns, because I already mentioned here max turns is 2. If you just mention it as a 10, it can work on the 10 turns, 20, 100, 1000 turns as well, until the critique is satisfied. Okay, so in that way, you can get the best possible output by having this reflection pattern. Okay, so I hope you completely understand that how this reflection pattern will work. Okay, so second we have is tool use pattern that enables the AI agents to interact with the external tools, APIs or DBs and resources that enhance their capabilities beyond their internal knowledge. And you can use it when tasks require the up-to-date information, because the large language model which we are using in the AI agent does not have the up-to-date information because of their training date. Okay, and then you need the real-time data there, and it can work as the agent automatically identifies by using the prompts when the external tools are required, and then it obtain the necessary information from them and perform the specific action. And you can avoid using this pattern when your internal knowledge of the large language model is sufficient to complete the task, as the external tools may introduce the unnecessary complexities to the AI agent. Okay, and the best example for this pattern is the travel assistance that can use this tool use pattern, where user can ask for flight details, best hotels as well, the prices of the hotels as well. And these AI agents can have access to the live flight information, live hotel information as well, because they can use the external tools such as the flight APIs and can get the real-time data for you and build a whole itinerary for you as well. So now let's implement it by using Python and Autogen Agentic AI framework. So here is our second pattern code that we use the tool use pattern here, and for that I build a raw Python code first, that is without any agentic AI framework. Okay, so for that we use our Google large language model, that is Gemini Flash, and then we use a SERP API here. This SERP API can be used to search on the Google as well. Okay, if you don't know about it, you can just go to this account that is called SERP API and create your account, get your own API key and start using multiple APIs that is already present here that can search anything for you: news, locals, lands, jobs, images, anything for you. Okay, so we use this kind of API here. So let me just create a simple function that whenever you pass a prompt, it will go to this search query that finds the latest news on this kind of a prompt that you pass, and then based on the information that we required, we have to search on the Google as well. So for that we just pass this search query into this kind of params, and it can search on the Google search and get all the information that it need, and then pass whole information into this kind of a prompt that we pass to the large language model. So now for our prompt here, it search on the internet, find the information, and then generate the answer for us like this. Okay, so now you see this, how we get the answer. Now let's try to make our model autonomous. Okay, we get to apply this tool use pattern here. For that we use the Autogen. For Autogen here we use the Google API key, our Gemini 1.0 Pro large language model here. We make a agent here first that we name as assistant, and then pass our large language model configurations here, and then we create a user proxy agent. So in the previous code we use the SERP API to search on the internet, but here we use the internal Autogen tool to search on the internet, that is called code execution configurations. For that we just make it workday is equal to web. So when we pass this kind of configuration to our user proxy agent, so whichever information is not present to our large language model, it can go online and search for that information as well. Okay, and for that I just pass here who should read this research paper by initiating my chat with this user proxy agent by passing my this assistant AI agent as well. Now this research paper can be very latest. Okay, our large language model, because of its boundary knowledge, the large language model does not know what kind of search paper it is. For that our large language model, our agent, has to search online for this search paper and then provide you the answer here. So it do the same thing. When I just pass this kind of a query, it goes to the assistant, and assistant use the curl command to download the search paper first and then try to analyze the text and then give me the information that I required here. And then at the end, based on the title, what kind of research paper it is and why should I read it as well, it gave me all the information present in this kind of a chat result. Okay, if you want to extract this chat result, you just try to do one thing: just save this result in a kind of a variable, and then from that variable just ask for the content kind of a attribute. It will give you all the result in a structured format like this as well. Okay, and that will work. Okay, so now let's move to our next pattern. Okay, so third we have is ReAct pattern. ReAct means reasoning plus action, and this pattern combines the reflection, that means the ability to analyze and improve their own generated outputs, and can take actions by using the tools such as searching Google or using the API to fetch the information. And you can use this pattern when you have a complex Q&A task, and when you want to build autonomous AI that can work all by himself without human intervention, and when you want to do AI research, and when you want to build dynamic chatbots as. Okay, and it can work as in a cyclic process, because it have these kind of steps: the think, act, observe, improve, and then answer. So in this kind of a cycle, this ReAct pattern will work. Okay, and you can avoid using this pattern if you have already static predefined answers in your vector DB, because the reasoning part in this kind of a pattern takes time, and that can add lag in your AI agent process as well. Okay, and when you also have the tool restriction as well, then you can also avoid using this pattern, because this pattern can need multiple tool access as well. And the best example for this pattern is in the medical diagnosis, where a chatbot might use the ReAct pattern, give you a reasoning about a patient symptoms, like symptom A and symptom B. It can suggest like that, can work like that, okay, in multiple ways. And this leads to a action of querying multiple medical databases, and by using multiple medical APIs as well. And this response is diagnostic suggestion or a referral to a specialist as well. Okay, so now let's implement it by using the Python and Autogen agentic framework by Microsoft. Oh guys, so here is our third pattern, that is called ReAct. So in this we use the Traverly here. Traverly is also kind of API that is used to search on web. Okay, so we use this API here, and we use our Google Gemini model API here as well. So a basic thing is we are trying to build a raw AI agent without agentic AI patterns. So for that, first I built a search tool here that can help to search on the web. Then I has to extract search query, because for that we need to extract a kind of a statement from our initial kind of output to know that our AI agent want to search on net or not. Okay, so for that we need to build this kind of AI agent that can help search this kind of a search action input kind of a keywords that try to search in the our initial output. And then we have this ReAct agent. So this agent works in a way that first it tries to generate the response based on the prompt that we have. So if I just pass this kind of a whole prompt, okay, and I just also mentioned here that if needed, perform a search using this kind of a format. Okay, so when I pass this kind of a prompt into my this initial kind of a large language model of Gemini Pro, then it will give me this initial text, and I just try to check if the action search or action input is in this kind of initial text. Then it tries to reflect on that and try to improve the response by using this Traverly search tool as well. I use the same tool here, try to extract and try to search and get the search result and put into the prompt and give me the final response as well. So in that way, when I just pass this kind of query into this my kind of agent, it will give me the initial response. Okay, this is the initial response, and then this will give me the final response as well. Both initial and final response are quietly same. There is no difference at all. That's the drawback of building the raw AI agents without any agentic AI framework, because it does not know when to search or when not to search. Okay, so now try to build it with the Autogen using an actual agentic AI framework and an actual agentic AI building tool that is called Autogen. So for that, we try to first build a kind of our agent here. We similarly call this kind of using the Tabili as well. And then we have this auto agent assistant user proxy register function. This register function is important because we need to register our this search function into our this AI agent. So that whenever required, it use this function to search on the internet. Okay, so first we build our assistant agent here. We name it as assistant, pass our large language model configuration, and then this is a system message that is you are helpful AI assistant. Have the access of a web search tool. If you need, you can search. Okay, that all information is given here in this. Okay, and then we build a user proxy agent that we use to initiate the chat. So for that, we just pass everything here, large language model configuration, maximum consecutive replies to 1, so that it should not go into the loop. Okay, and then we pass our system message and we register the function as our search tool to this kind of a AI agent, and this kind of a user proxy will call this as well. Okay, so when we just pass this kind of a simple function, what is the capital of France, and we try to initiate the chat with everything we have. Okay, and the reply message that we got is user proxy to our AI agent, that what is the capital of France. So it don't know what is the capital of France, so it initiate the action search. Okay, and then it's try to search on the tool that using this auto reply method, executing the function search, it search on the Wikipedia, the answer got it Paris. Then out of all the information, it give me the Paris is the capital of the France, and then terminate the code. So that's how the React tool will work. Okay, the React pattern, you can try to build this kind of a AI agent in that pattern. In this way, you don't need to do anything. Just try to set up a kind of a framework or kind of a workflow. It will work automatically for you. Okay, guys, I hope it completely help you. It completely help you and you really learn about the React Agentic AI pattern. So let's move to our next pattern. Okay, so the next pattern we have is planning pattern. So that pattern allows the AI agent to create roadmap by subdividing the task and outlining the objective for each agent that facilitate strategic thinking for effective task completion. In this, you have a team lead and you have a whole team, and the team will complete the task, and the team lead will check their task, collate it, and give you the final output. And you can use it when you are dealing with the multi-step task that require strategic execution, such as the coding, problem solving, where you need to act as a defense lawyer or as a prosecution as well. Okay, and it can work as it break down the complex task into smaller manageable subtasks and then plans the sequence of actions and then execute them, and can delegate the task to its team as well. And you can avoid using this pattern as it may be overkill for simple tasks that don't require detailed planning or can be completed in a single step as well. And best example for this pattern is software development lifecycle. The planning pattern breaks down the main task into sequential subtasks like requirement, design, development, testing, and then deployment, and then monitoring as well, for a successful software development and problem solving as well. Okay, so now let's implement it by using Python and Autogen Agentic AI framework. So now we have the planning pattern here. The planning pattern means it plans your task and by dividing into the subtask. Okay, so that's how the planning pattern will work. So we have the large language model configuration. This time we are using the Gemini Flash here. Okay, so our task is to know about the stock performance of a Nvidia in the past month, and today's date is 12th of March. Okay, so on that date we want to know the performance of a stock. So he need to search on the online, he need to search on the Yahoo Finance or multiple sites. He like our AI agent has to do lot of work here. Okay, so that's why we build these kind of agents. So first is the admin agent that allow the user to comment on the report and ask the writer to define it, and then the planner who plan all the tasks, and then the engineer who write the code and also execute it. Okay, and then we have the writer here that write the last report that we want. Okay, so first we create our admin here that give the task and send instruction to the writer to refine the blog post. Okay, we passed here code configuration no, because that is only a administrator here. We pass the human input required, yes, because this is the only admin that asks for the human input. Okay, that's why we put it here always. Next we build our planner agent. So planner agent is name planner. We give him a system prompt that what information is required, give a task, please determine, please note Python code, retrieve the Python code after each step, check the progress as well, everything around that. If anything fails, is try to restart the process and fix that issue as well without any human intervention. Okay, and then we build an engineer here, and engineer means that writes the code for the plan. And I also like mention here some kind of error that usually occur in this process, that how to solve it. Okay, and then I create an executor here that execute my code and report the result of that code as well. Okay, so for that I just pass here work tier into the coding, so it will run the code in a sandbox environment and provide us the actual result of the code. And then we have the writer. That writer will get the code, it will get the feedbacks and everything like, and then it will write a blog on the kind of information that we get. Okay, and then we have a group chat. This group chat means all these kind of AI agent will talk about each other to each other, communicate very well. Okay, so that if any issue occur, they can communicate and sort it out as well. We also make a group chat manager that manages all these kind of agents as well. Okay, then we just initiate it with the help of manager, and our task is defined above. So as you see here, I ask about this performance. The planner send this whole plan to the chat manager. We need to find the NVIDIA stock symbol, that is NVDA. We need the historical data of the past 1 month. Okay, first step 1, step 2, and then what are the kind of methods. It will use the Yahoo Finance library or the Alpha Vintage API to find the data. This is doing it all by himself. I am not kind of involved in any of this. Okay, then is try to speak to the engineer who will write the code. It will write the code here. Okay, and then it will try to execute it. Okay, and when it tried to execute it, it found a error here. Okay, and this error is also solved by the engineer as well. In the next chat, he will check it and try to execute it again. Again the same error comes in, and then it try to again sort out the error as well, and this time it will sort with the help of floating price number. And when the executor execute it, okay, the issue got away and we have the result here. And when we have the result here, and then our writer will check this result and try to write a blog, send it to the chat manager. Then the chat manager will check the blog and try to ask it for the final draft. So the final draft is here, that will tell us all about the NVIDIA stock, that how it performed as in the last 1 month, what is the analysis it says, everything is right down here. Okay, so that's how your planner agent will work all by himself, writing code, executing it, writing the blogs as well. Everything work well here. Okay guys, so I hope you completely understand that how this planner pattern will work with the Autogen. So let's move to the next pattern, that is multi-agent pattern. So the last pattern we have is multi-agent pattern. So in this pattern, we involve multiple AI agents, each with a dedicated role, task, and access to the tools. And these agents collaborate, delegate tasks as needed to achieve a common goal. And this pattern is best for the complex problem when you have a distributed systems and when you have a scalable workload, and when you want to enable the coordinated task distribution as well. Okay, and this can work as each agent possesses specific skills and knowledge and can communicate with the predefined protocols, APIs, shared info as well, and can delegate tasks to the other agent and can improve the performance as well. And you can avoid using this pattern if the tasks are simple or the added communication is a overhead or a overkill for your model. And the best example for this is the financial institutions, where we can implement a multi-agent pattern system to simulate the market dynamics, where individual agents represent the buyers, sellers, aiding in the understanding market trends and the behaviors as well. So where multiple agents do work and can give you the proper output at the end as well. Okay, so now let's implement it by using Python and Agentic AI framework as well. Okay. Oh guys, so this is our last pattern, that is called multi-agent pattern. So multi-agent pattern and the planner pattern that we just discussed above, they are not very different. They have just a difference in the source of their execution. Okay, so let me show you that how it works. So we have this multi-agent pattern. We use the same kind of large language model here, but here is the difference, that we made a user proxy function, that is the admin. So let me just give you first the task. What are we actually trying to do? So we are trying to build a Python code that will help us find the latest research papers on the archive.com on the large language model applications. Okay, this kind of this whole kind of multi-agent will try to build the code, and after building the code, try to fetch those kind of papers and then try to summarize those papers for me as well. All the tasks are done by this multi-agent pattern AI agent as well. Okay, so first we build a user proxy here, that is the human admin that interact with the planner to plan and execute it. So here is the difference between the planner and the multi agent approach is that in this, the planner does not oversee on all the kind of the agents as well. All the agents work independently. They don't have anything to see, anything to check their progress as well. No, the planner here just to plan, and all the other agents are trying to execute it. That's it. So that's the difference between the planner and the multi-agent approach, that in the planner has to oversee, check the progress as well, but here it don't need to check the progress. So we just build an engineer kind of thing that will do the Python code for us, try to build the code that will fetch all the latest papers from the archive as well. The scientist is try to recognize those papers after seeing the abstract of them. You don't write the code. Okay, then we have the planner who plan all the things. Then we have the executor that execute the code and give us the results. And then we have the critique. That critique will check the result given by all of these agents are true or not, that how good they are. Okay, so all things are checked by the critique. And then we have the group chat, then we have the manager. Everything is same as the planner. So now we just try to run this code. So first the speaker goes to planner to plan it out. So it will give a plan. That plan is to LLM application domain analysis from the archive to create a markdown table. Okay, we need this, and then the engineer will write the code. The scientist will responsible for reading the efforts. First we do the data retrieval. For that we need to write a Python script and then store in the kind of structured format. Then deliverables would be a CSV format. Okay, so that all is planned by the planner. And then we have to filter the data for the primary subject category that we want. Okay, then we have the abstract review and the domain identification that can be done by the scientist. Then we have the table creation. It is also done by the scientist. Then we have the iteration and the refinement plan that can be done by the admin or the critic. Okay, all of these are done in a one chance. The planner plan all of this. Okay, once it all got planned, then the control goes to the chat manager. Chat manager says to the engineer that engineer will try to write a code. So it first write a raw code here, and the execute is to run it. It shows that no module name archive. That means we need to install the archive library, and it done all by himself. It just write the code here, pip install archive, and try to install it. After installing it, there is another error come, that is the no module name tabulate. Then it also try to install the pandas, tabulate, and the archive all the modules as well. And after this code goes to the executor. Executor run this code. It gave me this kind of a whole table that has the published, URL, abstract, and authors. Now we need to get the summary of all the kind of abstracts. So that code goes to the scientist, and the scientist will try to read papers, identify the primary applications, write a concise summary as well. It do the thing. It first get the domain, paper title, authors. And on the way of that, it try to make the summary. Then the thing goes to the critic. The critic will check how your response is. It says your response is very thorough and well structured. You successfully address the prompt. Now, here is the breakdown of the strength and the improvement areas. So all these kind of improvement areas are done again by the kind of a critique to the chat manager and try to summarize what things to do done. And then the critique and the chat manager will try to talk it. And after all the talk is done, it will give me all the kind of the result at the end. So that's how this whole analysis is done by these kind of multi-agent approach. Okay, agentic AI patterns can make your AI agents more autonomous and more powerful as well by using multiple kind of large language models like Gemini, DeepSeek, and many more as well. Okay, guys, I hope you guys completely understand that how this completely works. And in our next video, we try to build our first AI agent project by using the DeepSeek. Okay, we try to build a reasoning agent that can reason and then try to give the answers and try to do the task as well. Okay, so just be with it. And if you want to know more about generative AI, prompt engineering, machine learning, or data science, you can watch my videos on YouTube and also read my blogs on Medium. We'll meet in our next video. Thank you guys. Thank you so much.